Are you running AI or ML workloads in Kubernetes? Tired of manually managing GPU drivers and configuration? What if I told you there is a way to automate it all? In this video, I will show you how to set up NVIDIA GPU Operator in Kubernetes to take the hassle out of GPU management. Welcome back to the channel. I am Nikhil Kumar. Today we are diving into NVIDIA GPU Operator and how it manages GPU resources in Kubernetes. If you got some powerful GPU nodes and you want Kubernetes to handle all the setup for your high performance AI and ML workloads, this is where the NVIDIA GPU Operator steps in to make your life easier. The NVIDIA GPU Operator is like a manager for GPU resources in your Kubernetes cluster. Its primary job is to detect any GPU enabled nodes and set them automatically, so they are ready to handle the GPU heavy applications. The operator does two things. First, the driver installation. The GPU operator scans each node to see if it has a GPU. If it finds one, it installs the NVIDIA drivers needed to run the GPU workloads. This is essential because without these drivers, the GPU can't function properly with Kubernetes application. Once the drivers are installed, the operator also manages the GPU resources, ensuring that each GPU enabled node can efficiently allocate resources to demanding workloads. This way, application access GPU power automatically when they need it, with no manual intervention required. So if you see in this diagram, we have two GPU nodes. The operator installs driver on these nodes and configure resource management. Think of these nodes as your specialized workstation, always ready for high performance tasks. And we have one non-GPU node. If a node doesn't have a GPU, the operator simply skips this. These nodes continue to handle standard workload, so you are not wasting resources on GPU configuration here. Now, first step is to have a GPU node in your Kubernetes cluster. If you are on cloud providers like AWS or GCP, they offer GPU instances so you can use them. After adding GPU node, you can verify their availability in the Kubernetes cluster using kubectl commands. Next, let's install the NVIDIA GPU Operator using Helm. Helm makes the installation and future updates straightforward. First, let me update the Helm repository here using the command helm repo add NVIDIA and the repository link. Repository got added for the NVIDIA. Let me update the Helm repository, Helm repo update. And let's briefly go over the key configuration in the values.yml to customize the GPU driver to be installed. So that there is a values.yml for the GPU operator. So these settings ensure that GPU operators know where to find the containerd configuration, socket, as well as making NVIDIA runtime the default, allowing GPU workload to use it directly. If you notice, here we have pointing out to the containerd config template. Below that, we are giving up the containerd socket path. And at the last, if we see, we are making a containerd set as default. Basically, we are making NVIDIA runtime the default for the GPU nodes. And above that, we are setting the runtime class for the GPU node, that is NVIDIA. Now run the helm install command to install the GPU operator. For that, we will be using a command helm install GPU-operator and the chart name NVIDIA slash GPU-operator, and then put the namespace under which namespace we need to create the resources, that is name GPU-operator. And then we will be giving a flag called create namespace. If the namespace is not there, it will create that namespace. Then we will use a wait flag. It will wait for the deployment to be completed, and then we will need to specify the file, that is our values.yml file, and press enter. With this setup, the GPU operator will detect the GPU enabled node and handle the driver installation automatically. Once our GPU operator is installed, you can check its status by listing the pod in the GPU operator namespace. So kubectl get pod -n GPU-operator, and you can see that the pod is getting created. So let me run the same command again. It's getting created. It will take a couple of more minutes to complete this installation. So if you see, it will be deploying components like NVIDIA driver daemon toolset, device plugin, and the DCGM exporter to get the metrics out of it, and also deploying the toolkit, which will be used to install the driver and automatically detect the GPU node. And so if we run this command again, so It will take a couple of more minutes. Now we can see that all the pods are running and our GPU operator is working fine. If you followed my previous video on creating a GPU enabled pods, this next part will be very familiar. You can define a Kubernetes pod with a GPU request like this example, that is GPU pod.yml file. And here I am specifying the TensorFlow image for GPU training. And we are specifying the GPU count to 1. And let's create a pod using this. kubectl apply -f GPU pod.yml, and we can see that pod got created successfully. Let's verify that, and we can see that pod is running 5 seconds ago. Let me clear out the screen and let me check the driver, is it working fine or not on the pod. kubectl exec -it pod name -NVIDIA -SMI, and we can see that driver is like working fine. And we can check again the GPU operator pod status. And okay, let me see GPU operator, and we can see that all the pods are working fine. With the GPU operator in place, you are set to run AI workloads on Kubernetes without worrying about manual GPU setup. For optimal performance, make sure to monitor your GPU usage with tools like Prometheus and NVIDIA's DCGM exporter. I will dive deeper into GPU monitoring in future videos, so make sure to subscribe. That's it for today. If you found this helpful, give it a thumbs up and share it with your friends. And don't forget to check out my previous video on creating a GPU enabled pod if you want more details on this pod setup. Thanks for watching. Have a nice day.